Hello, everyone. Java is an object-oriented language, meaning it utilizes objects in program design and implementation, and objects are modeled from real world. So, the object is a fundamental software building block in object-oriented programming that represents some concept or entity. Like an employee, right? As I told you today, I am trying to create a certain application about maybe a workplace, a certain workplace, and this workplace has employees for sure. It has some managers, and other staff. For employees, I'm creating a class. I call this class employees, and I define the different features and characteristics of each employee, meaning that each employee might have an employee ID, might have an employee name, and maybe an address, a phone number. So all the different details related to this employee. And I would say here, this class or this employee object represents an actual person who works for the company, meaning that this class called employee, I use it as a template and I make several copies out of this employee class to model all the employees that work in the company or the department. So instead of writing the code for each employee who works in the department, I will create a class and I call it employee, and using a technique called object instantiation, I will create multiple copies of my employee. Each employee will be unique in some points or some characteristics. For example, of course, the name is different for each employee. The address is different. The phone number is different, and also the ID. So each employee will have their own ID. So they all share the same characteristics. All employees share the same characteristics in terms that they all have ID, they all have address, they all have a phone number. However, they are different because the information related to each one is different. Okay, so we call this instantiation or making copies of each class. Um, and also, I can include behaviors to my employee. So, for example, calculate payments. I can create a function called calculate payment or calculate salary for this employee. Submit a timesheet for each employee to be able to submit a sheet, and so on. So there are different behaviors relevant to that employee entity. So this technique is very useful because it allows for mass production of code, okay? And I can model the whole entire company using this way, okay? And each employee object would independently manage the data and processing for that single employee instance. And this ability to map program elements directly to things in the real world is actually a core principle of object-oriented modeling that Java manages effectively. Now we are going to talk about objects. The two main aspects of an object are its state and behaviors. State here refers to the attributes or properties that describe an object or the data values associated with it, and we define them using instance variables that are written at the beginning of any class. The second attribute is the behavior. Behaviors are the actions or methods that the object can perform. Methods here mean functions. This includes things that the object can do itself as well as things that can be done to it. So, for example, let's talk about I want to create an application for a bank account. So this could include information like account number and balance, and current balance, which describes the state of the account. And then the behaviors of the bank account would allow depositing funds to increase the balance and withdrawing funds, which decrements the balance. So behaviors potentially change the object state. The behavior affects the state, right? Because why? Because depositing and withdrawing will affect the balance amount. So that's why behavior, which is the function, when it runs, will affect the value of the state or the value of the balance. So the object itself is instantiated from a class or defined by a class. The class here acts as a blueprint or a template. It describes the general properties and behaviors common to all objects of this type. The class defines a general concept. Okay, it defines a general concept, like for example, a dog. Okay, or a certain item that is available or existing in real life that we are trying to model. Which here is a dog. It could be a table. It could be a chair or anything. So, but the objects, so this is the name of the class, dog. Okay, that's the name of the general concept, which is the class. When I say my dog, this is something unique. I have to define some unique characteristics that that are related to my dog. When I say your dog, so I'm defining other properties related to your dog. So in this way, I can create multiple unique objects based on the same class definition, right? I defined a general class definition, and based on that, I can create multiple unique objects. So the class specifies only the common behavior, and each object can have different property values. So in this example, I'm just talking about how the class is defined as a blueprint. The blueprint defines all the core features and elements that make a house. So I'm defining the walls, the doors, number of windows, electrical wiring, plumbing, and other aspects also. So this specifies the general template or outline for what a house is, but it doesn't define the specifics of any a certain house. So when the builders use this blueprint to construct houses, they are creating individual house objects based on that class definition. Each house object of these will be constructed following the blueprint. Okay, so it will follow this blueprint, but will have unique characteristics. For example, one house may have the wiring in a different pattern, a larger kitchen, or wood floors instead of carpet. So this will be the individual property values of that house object. So the blueprint itself or the general template doesn't change. It is reused. It keeps being reused as a design for creating many similar yet distinct house objects. So the same class can be utilized to instantiate any number of house objects. They function equivalently, but they have their own unique attributes. This is another example to highlight how I can instantiate or make the model of my objects out of the class. So I have here the class, which is called bank account. So that's the main or general concept, an account, and I can create several objects out of this account. So I have a specific account related to John, another one for Bill, another one for Mary. They all have different balances, but they are all following the general concept, which included the name of the person and the balance. Finally, inheritance is a concept also in Java where it allows for hierarchy, meaning that these accounts, these specific accounts, here I have savings and checking accounts, they are following their parents, which is the bank account. So they are following their parent, meaning that they have the same attributes, they have the same methods, but maybe the code inside is each method is different. It acts in a different way. The attribute, the value of the attributes could be different as well. We'll talk more about that when time comes. We'll expand our talking about inheritance during the designated chapter. Thank you, everyone. I hope this helps.